This is number 7 on the force section of part two of the performance honors performance final review. Number 7 says, I have a 275 kilogram sled. That's its mass because it's in kilograms. It's pulled by one very strong dog to the east against a 100 Newton force of friction. The sled has an acceleration that's given to you 3 meters per second squared. I need a free body diagram that is going to have all of the 4 forces. You should have the dog and the force of friction, as well as the weight and the normal force in the y direction. And then I kind of walk you through the steps. What is the weight? What is the normal force? What's the net force? And what must the applied force be? You can solve this you can solve part E before part D. It doesn't matter because you'll see when we get there. So pay attention. Here we go. First things first, free body diagram. So I want one of all of the forces, horizontal and vertical. So if this is my sled, I know that my mass is 275. I'm going to have its weight down and the normal force up. That's the force that the ground supports it with. I'll fill in numbers in just a second. So then I've got the dog is pulling to the east. So this is going to be the force applied from the dog, and I don't know what it is just yet. And it's pulling against a 100 Newton force of friction. And force of friction always opposes the motion. So since it says it's moving to the east, I know that the friction is working against it, pulling back to the left. All right, let's go ahead and get some numbers on here. I've got the mass, so I can figure out the weight using the equation Fw equals mg, where here on Earth, lowercase g is 9.8. So Fw equals my mass times 9.8. Multiply those together. To 2695 newtons. So that's the side part. I can go ahead and then label this is 2695. And because it's not falling through the snow or being propelled up into space, then there's only one up and one down. The force is balanced. So the normal force is also 2695 newtons. I'm going to go ahead and work this problem like we've done in class. And then at the end, I can answer part A, B, C, and D. Great. So then I need to know, I also know the acceleration is 3 meters per second squared. Remember, you to the east. You can't draw that on your free body diagram. The only thing that goes on here are forces. Make sure that you have them labeled with letters and that you have arrows on them. Okay, we've got the mass and the weight. We have our free body diagram with all the arrows on it. And the last thing we want to do is sum the forces set it equal to MA. Okay, this is only going to be for the x direction. We already know that it is not accelerating up and down. So I've only got 2 forces in the x direction. I've got the force applied by the dog and then minus the force of friction. And so I'm going to plug in the numbers that I have. So I don't know my force applied. My force of friction is 100. The mass is 275. The acceleration is 3. And add my 100 to both sides. The applied force must be 925 newtons. Once I get this, I can go ahead and put it back up here. And then I've got everything that I need to know to solve to completely answer these questions. So let's go through and see what they said. Part A was draw a free body diagram. Check. Part B, what is the weight of the sled? So part B, and you can write down here, but if you have your arrows up here, then that counts as your direction as well. But weight is 2695 down. Part C asks what is the normal force on the sled, and so I can just look up here. My normal force is also, this one is up. Part D says what is the net force? Remember we said the net force is either half of this equation. I can do this to come up with the net force, or I can do this to come up with the net force. So 825 would be the net force. Or if you want, go ahead and go up here and look. We've already solved it out. F net is just a fancy, or I guess a non-fancy way to say some of the forces. So I've got the 925 forward minus the 100 backwards, and my net force is 825. And then part E is what must the applied force be from the dog, and the applied force is 920. And so there are my answers.